screen and voice both?
Yes, sir.
Yes, sir, both visible.
Okay, okay. Thank you. Thank you. So today class day number, what is the class day today? So far we have
14,
done
14.
Sir.
14.
so far we have done 13 classes. So today class day number 14. Okay. Class day of 14, and we are discussing about the module 2 of the syllabus. So far we have done only module number 1. Module 2 is going on. Yeah, okay. So coming back to the syllabus, what we have discussed so far. So like module 1, that is the introduction and overall project process. This understanding we have discussed. And after that, we started the module number 2. In module number 2, we are discussing about the equipment selection and their sizing or rating calculations. And so far we have covered about the lightning or surge arrestor, their selection based on the voltage level, and their rating calculation based on the voltage level. And after that, we started about the CT, current and voltage transformer, CT and VT sizing. So we are following the same sequence. In that sequence, we prepared the single line diagram, or the same sequence in that we install the equipment at the site. So let us have a look to the SLD, and then some site photo as well. So this is a 220 by 33 kV SLD for a 300 megawatt power plant. And here we are starting from the line towards the line side. So this is the first equipment that we have. So we have discussed about this equipment, right? The rating symbol rating calculations, and why this equipment should be the first equipment, why this equipment should not be the middle equipment or the last equipment. So I hope that this equipment is clear to all of you, that we have discussed. And after that, we have discussed about the CT sizing calculations, correct? So far, two equipment that we have covered out of all the equipment that we use in the substations. Like here we have a 3D view of the substations. So in that we have the common bus bars, and then we have any feeders bay. So in that we are discussing about each equipment, their selection, sizing calculations, and the sequence of interconnection. That why this equipment should be the first equipment, why what equipment should be the second equipment, what equipment should be the third equipment. So here this is the CVT, surge surge register here SC, and after that we have the CVT, and after that we have the wave trap, and after that we have the current transformer CT. So this CVT, capacity voltage transformer, and the current transformer both comes under instrument transformer. So due to that we have taken both equipment all together. And so far we have discussed about the current transformer. Today class is very much important, so please focus, and I need the full attention of all of you. And today topic is a disputed topic, means different country, different engineer have different opinion. So I'll try to say about my opinion, but maybe one could have the different opinion about that. So please focus and try to share your opinion as well with us, that what practice you follow. Little bit disputed topic today I pick for the class, and this is the additional topic. This topic I do not discuss usually in the class, but I thought let me discuss this topic with all of you, so that the engineers who are not aware, they will know about us, about that topic, and others who are already working in the field, they can share their own experience with us. So I'll come on to today's agenda. We are just discussing what we have discussed so far. So we have discussed about the surge arrestor, this equipment selection sizing, and why this equipment should be the first equipment. After that, the second equipment, here it is a capacity voltage transformer. Third is the wave trap or line trap. Fourth is the current transformer. So we have taken CT and CVT both equipment together, and so far CVT we have not covered, but CT we have covered. So in the CT sizing, we have seen, even though this equipment look like this, but this equipment is constructed inside this equipment. We have the primary winding. In primary winding, we take just one winding, or this conductors self work as a primary, and after that we have the secondary windings, and we discuss that in substations we take the multi-core and multi-ratio CT. So we discuss that when it comes to the CT sizing, so we have to do the sizing core wise. That is what we have discussed so far, right? So we have discussed what the type of the core we use, what should be the number of core based on the voltage level, and about each core selection and their rating calculations are the parameters we have discussed so far. Last class we have discussed about the CT, about the PS core or PX core, and their knee point voltage calculations. This is what we have discussed in class day number 13, correct? So any doubt regarding the CT knee point voltage, VK calculation? Our class day 13. Let me know. Today I'll come on some different topic which is out of the syllabus that generally I will do not cover, but I thought let me discuss in this batch. Okay, Suraj. I hope so far I'm clear. Any doubt?
Yeah, it's clear, sir.
Okay, so today agenda would be the location of the protection CT installation, where it should be installed and why. Why the circuit breaker should be under the bus bar protection zone, location of the CT in GIS type substation, location of the CT in HT panel, polarity of the CT means P1 and P2, their choice, core allocation choice, and along with the protection CT, we have the metering CT as well. If you see, I'll share you some project single line diagram. You can see here we discuss a lot of things about this CT, but along with this CT, we have one mode CT. So you can see that CT over here. This is the outdoor tariff metering cubicle. This dedicated CT and VT here we have. This is called the tariff metering or dedicated revenue metering. So where we take this, what is the purpose of this, and where we should not take this? What is the use of this? And the difference between this and this CT sizing calculations. So there, the dedicated tariff metering CT and VT, that I will take as per the Asian practice and as per the UK national grid practice. And then CT types, it could be a phase CT, it could be neutral CT, it could be the bushing CT. What I mean by that, if you see the single line diagram, this CT like winding looking like this, but when you see this the SLD, and when you come on the transformer, in that the same CT symbol change like this. So I took this point so that if you see this kind of the symbol in the SLD, then what this symbol representing? So this symbol is the bushing CT, bushing type CT. So why we use this? And after that we have a neutral CT also. So choice whether this neutral CT in this particular diagram, this neutral CT is inside the transformer bushing, correct? I need some participant who are working are experienced. So please unmute and try to share your experience with us. So that means others who are new, they can know each and everything about the CT for the service station. Correct? Today is like some additional things I want to discuss. Due to that reason, I took this point. So yeah, about this neutral CT, where it is required, why required, and the choice means this neutral CT, whether it is mandatory put in the bushing and or we can put outside. So about that CT. So CT types, why neutral CT and CT is required, and what should be the neutral CT current ratio. Means we discuss a lot of things about the phase CT, but what about the neutral CT ratio? What should be their ratio? And then why VT, type of the VT, difference in VT and CVT, VT and CVT rating indication in SLD, open delta or broken delta. This is a different topic. This is very much less in the use, but sometimes when you see this broken delta or open delta VT, open delta VT, so why we use this? What is the purpose of this open delta VT? that we will discuss, then CVT nameplate, and then what we should look at in the VT specifications. We have discussed in CT specifications, we will discuss now VT specifications or VT sizing calculations, and then why carrier communications required into substations, or our techniques for carrier communications, and then I will come on the line trap or wave trap. So this is the overall topic that we have planned for this weekend. I'll try to take most of the topic by today. So I need your 200% attention, because this topic is out of the syllabus topic that I'm taking. So I'm dedicating my extra time. So I need your extra attention. That is the only request I have. So I have given the name city discussion with SLD preparation and sequence of equipment interconnection point of view. Means we have discussed CT rating calculation, but I'm going beyond that discussion, and we will discuss the CT, but how we will prepare the SLD in that way, in that point of view, and whether CT should come before the breaker or after the breaker. Means if I go to this single line diagram, if you see the single line diagram, I have placed this CT after the breaker, right? I have placed this, so I have the bus bar after the breaker and then CT. So is it, if I place the CT not here, over here, so is there any problem? Why not here? Means actually I'm taking this topic when you are going for interview, you are preparing the SLD, that would be the cross question. So how you will counter that questions, how you will reply those questions during the interview time. SLT is very important topic for the interview, and you will face a lot of counter questions when you are making the SLT. Just because they wanted to know that whether you have the in-depth proper understanding about the SLD or not. Due to that, there would be counter questions about the equipment interconnections. So is there any, let us start by taking the like response of the some experienced engineer. If I put city not here or not breaker, before breaker, so what would be the problem? I need some reply here, please.
We cannot take the maintenance.
Yeah, yes, sir. During maintenance time, let's suppose after maintenance, if we have to close then if there is a fault in that, then it will not be taken for SOTF function and all.
The city is required to cover certain zone of protection. So that zone of protection is quite important. So that coverage decides the position.
Please come with interview point of view. You are in the interview, I'm asking you why you are putting here to here. So do not tell the incomplete answer, tell the complete answer. Certain zone of protections, which you can tell all the protection zone, Suresh, that we have line protection zone, we have transfer protection zone, and we have bus bar protection zone, right? Like that. If you tell, that would be more comprehensive reply. Anyway, thanks, Suresh. Anyone others? Anyone others?
Yes, sir. Is I audible?
Yeah, audible, yeah.
Yeah, let's suppose, sir, the breaker is open for maintenance purpose, and after that, if you are closing that breaker, there will be a function called SOTF.
Yes,
And
correct.
for that region, if there is a fault in that line, so that SOTF function will not activate if the city location is after the breaker, because the
Before the breaker, right?
fault cannot.
Before.
Before. Yeah. I mean,
Okay,
because the
SOTF.
fault will not be sensed.
Okay, I'll note down your reply yesterday. So SOTF stand for the switch on to fault. Okay, and when you are closing the breaker, right? Yeah. Come on, Astikil, you complete.
Yes.
Reply.
While
Let me make the SLD. Let me make the SLD. I'll come on the detailed discussion. So others who are not aware, please do not hesitate. I'll start with in a very simple and sequence manner. I'm just discussing Astikil, what is their experience. So yeah, here I'm putting the
while
and
CT,
after that I'm
yes.
putting the circuit breaker here, and thereafter we have a outgoing transmission line or outgoing feeder. And suppose this is my substation boundary here. So SFTF basically work within substation boundary, right, Astiki?
Yes, sir.
So
Exactly. For
yeah,
that particular breaker.
yeah, here, so any fault happens. Yeah, okay. Now, you
If
know,
if any fault happens and the breaker is open, then the fault has not been detected by that particular CT. So while after closing only, it will detect that fault. So that SOTF will fail in order to trip that breaker.
okay, so
So
this could be one reason that due to that reason also the breaker should be placed after the CT, right? CT should be
yes,
placed
sir.
after the breaker. This is one point, so that SOTF would be detected by CT.
Sir, one that is it coming from line side or bus side? Actually,
Line side, I'm taking this is my bus bar, and here I have the line. So CT is on the line side. Okay, this could be one reason. Okay, SOTF. Any other reason?
Uh, Sir, can I try the another reason also?
Yeah.
Let's suppose that the breaker is in open condition, and now the zone of any protection is from CT to CT. So the line protection zone will be compromised because since the CT is after that breaker and breaker is open, so the protection zone means for the remote and CT will not find its able to find its zone one properly. So there will be a zone problem in this case.
I'll take this zone problem and I'll discuss with in a very systematic manner, Astika. Thank you for your response. Okay, let us start. Let us start with a. But this is very much important for the SLD preparation point of view. So please concentrate. Uh, uh, and I told you this is disputed topic, so means few engineers may have different opinion as well. So please share your experience as well. So location of the protections. So I'm telling this city. Now I'm telling this city as a protection city and this city as a metering city. The reason is that because most of the city core utilized for the protection purpose. If you see this city have the 5 core, out of the 5 core, 4 core is utilizing for the protection purpose. You can see here like distance main 1, distance main 2, and then here we have the BCU. This is also one kind of the protection. BCU is a relay, and then trivector meter. Just I'm using 1 core for the metering purpose. And again, this 2 core, this is for the bus bar protection, and that could be also for the bus bar protections. So out of the 5 core, 4 core utilizing for the protection purpose. Due to that reason, I'm telling this CT as a protection CT. Now I'll discuss about this P1, P2 polarity, where this P2 here, this P1 here. This is very much important. When you are making the SLD, you must mark the polarity P1 and P2 because it is not only important for the marking and SLD purpose. Based on that, the CT when it is installing at the site, means when you are at the site and you need and the site engineer need to place the CT, need to place the CT. So where they will place which polarity means they must know that whether P1 should come here, P2 will come here, or otherwise reverse. P2 will come here, or P1 will come here. This is important. So the site engineer will take that information from your drawing. So minimum in single line diagram and in the layout plan and section in the layout drawing. This polarity marking is must important. So please make down when you are making a SLD, make sure you have marked the polarity. Like you can see in this case, polarity P1 and P2 is marked. So I'll discuss about that polarity marking as well. So now this CT I'm telling as a protection CT, and this particular CT is utilizing for metering purpose only. So I'm telling this CT as a metering CT, dedicated metering CT. So now I'm discussing about this protection CT. This CT selection and sizing calculations we have discussed so far in module number 13, like class number 13. So today we'll discuss about this location, choice of the locations. where we should install this in a line bay or in any bay. So that is the point. And I'm taking both three kind of substation. One, it could be AIS, or it could be GIS, or it could be HT panel, indoor substation, or HT panel, metal enclosed HT panel. In that, what is the choice of the city locations? So let us start first with the AIS. So for the AIS substation, the correct location is to install the CT. This CT is here, breaker is here. This is 400 kV circuit breaker. This is current transformer CT over here. So just to install the CT just after the breaker, which means just after the breaker, and like I can rewrite this and towards the protective equipment side. Protective equipment side means if I take this single line diagram, here I have the line bay. So in this case, the protective equipment or protection zone would be my line zone. Line bay would be my protective equipment. When it comes to the transformer, so in that transformer bay, my transformer is the protective equipment. I need to protect transformer in this bay. So it means CT would be installed towards the transformer, right? Towards the protective equipment side. There is again reason why this will minimize the short circuit current. This will minimize the short circuit current conductor covering length. Conductor covering length, what I mean to say, conductor covering length. Conductor covering length means suppose you are not putting CT over here, you are putting CT over here. Means I told that the CT should be after the breaker, but after the breaker it could be anywhere. It could be here, it could be here, it could be here, anywhere. But after the breaker and just after the breaker means here. Why? Because if CT I'm putting not here, I'm putting over here. If any fault happened, so what will happen? The fault, if CT is over here, so when the CT will sense the fault, when the current will reach to this CT equipment, right? Then only CT will sense the fault. But if they're passing to a 3 equipment, so those equipment first face the fault current. I need at least one engineer attest so that they can respond whether they are getting my point or not.
Yes.
Yes, sir.
I'm telling, suppose I'm putting, here is the bus bar, and then circuit breaker. I told you that CT should be after the breaker, but after the breaker and just after the breaker. Why? Because if CT is not over here, first I'm putting any other equipment. Suppose first I'm putting the disconnectors, right? And after that I'm putting any other equipment, and after that I'm putting the CT over here. If fault happening, so CT, when it will sense the fault, then when like breaker is here, so fault will travel all together to the disconnectors, and then it will reach CT, and then CT going to sense, going to feed relay, and going to breaker relay going to issue the trip command to the breaker. Means fault current covering more conductor length. So I wanted to reduce that conductor length. So after the breaker, but just after the breaker means here I have to install. So this is the reason number one. I wanted to reduce the conductor covering length by fault current, and assuming that most of the fault will happen on the load side, not on the bus side, on the load side. When placed after the circuit breaker terminal fault, this is a second reason which is very much important. The circuit breaker terminal fault or any fault between circuit breaker and CT will come under the bus bar protection zone fault. So the perfect or ideal reply, why CT after the breaker? Why CT after the breaker? The shortest and perfect reply, because the circuit breaker terminal fault or any fault between the breaker and CT, we wanted to cover under the bus bar protection zone fault. right, Astaki? When placed after the CB,
Yes,
the
sir.
CB terminal fault or any fault, CB terminal fault because CB is load making and closing equipment. It makes and open when full load current is happening. So the probability of fault at breaker terminals are breaker equipment is higher compared to any other equipment. So the breaker terminal fault or any fault between the breaker and CT that could be here as well. Please mute. Fault between breaker and CT will come under the bus bar protection zone fault. So when this fault will come under the bus bar protection zone fault, so due to that unnecessary line feeder tripping can be avoided. This could be a point that may not be clear. So do not worry because this is not the we have not discussed the about the protection module, which is module number 12. So when we will reach on the module number 12, in that we will discuss protection in detail, then this point would be more clear. You just note down in your note, this is that breaker should be under bus bar protection zone fault. When I will come on the module number 12, in that we have the protection module. In that I will discuss about all type of the fault and the protection zone.
Excuse me, sir.
Just let me complete. So when any fault on the feeder, when any fault on the feeders occurs, means why this breaker on the bus bar protection zone fault. Why I am telling like that? Why breaker fault between at breaker terminal or between breaker and CT should come under bus bar protection zone? Why this reason? So why breaker should be under the bus bar protection zone? When any fault on the feeder occurs, both side of the feeder protection relays are operated. Means if it is not clear, so I can tell like that. So here I have a substation. This is my sending substation, it could be, and here I have a receiving end substation, substations. So this is my bus bar, and then we have the breaker, and then we have the CT, and the transmission line is going from this substation, and then it is entering to the next substations. And here again we have the CT and then circuit breaker, and then again receiving bus bar. So the point is that when any fault happened on, this is my feeder or line, which is connecting to substations. To substation, it is connecting line feeder over here. So if any fault happen on the feeder, then the relay which is protecting this transmission line. So both relay, this relay and this relay, both relay and both relay will communicate to each other, right? Correct. I need some
Yes.
reply from the protection engineer. Yeah.
Yes, sir.
So both relays are communicating to each other. Means both relay will get this fault informations, and both relay will issue the tripping command to their corresponding breaker. That fault happened, open the line, isolate the line. So now what happened? If you are taking breaker you are not putting over here. Breaker, suppose you have placed over here. Suppose breaker you have placed over here. So what will happen? Fault happening, a breaker is over here. Okay, fault happening at your breaker terminal. Are fault happening between CT and breaker here, somewhere here, but your and when this fault happens, suppose this fault is in zone 1 of this line. This zone we have discussed in class day 13. So please, others, please go and check there about the zone 1. So suppose fault happens in zone 1 of this line substation. So First of all, this relay going to sense this fault in they are under zone 1. They are sending interpreting command to this relay, and that relay going to isolate the circuit breaker. Means when the fault happens in the line, sensing the zone 1, issue the tripping command to breaker, and this intertripping command to this relay and this breaker as well. So if breaker is here after that CT, breaker is here after the CT, again, even though fault happened in your breaker terminal or fault happened in your local substations here, fault happened, unnecessary your relay sending tripping command to remote substation. Is this point making sense?
Yes.
Yes, sir. Yes, sir.
Yes, sir.
It's basically differentiating between the bus bar fault and the line fault.
Yes.
That is what I understood.
Yes, differentiating. So how I'm differentiating, that I am putting CT after the breaker and CT after the breaker, and I'm ensuring that let me see here. Let me take this point. I'm ensuring. Let me make it large. Let me make it large. So differentiating, and how I'm differentiating means I have the breaker here and then CT here, and CT I have different core. We use the multi-core CT. So this core I am assigning for line protection, and the extreme last core I'm assigning for the bus bar protection. So, and they will look like that, and they will look in this directions. So if this CT is assigned for my line protection, so if any fault happening towards the line side from here to here in line side, so only that CT will look those fault, and then issue the tripping. The relay will look those fault, and then it will issue the tripping command to the breaker. But if in case it is not happening like that, if my CT over here, breaker over here, so it means all the fault my CT going to look, right? Correct? That's why I told give you 200% dedication, sir. Yeah. Let me invite any protection engineer. Yeah. Speaker, any PNC engineer, they please come out and
Yes, sir.
speak their share their experience. Yeah.
Yeah. Here, sir, I just want to share one of my experience. Actually, in Delhi Transco, mostly in GIS, one practice is there, which I want to share with you. Like what they used to practice is they used to go with a split city method.
I'll
Like
come on
one
that.
city.
See, I'll come on that.
Yeah.
That you
Okay.
this is our agenda. So when I will come on here, then you will tell. Okay, Astakir?
Got it, sir. Yeah. No worries.
Let us stick first AIS. Let us stick first the AIS. Yeah. So let me again repeat. What is the doubt here? What is the point here? Who asked me to repeat? Please tell me your query. I'll repeat, taking you in the loop. Yeah, tell me. Yeah, so basically I'm differentiating by placing CT after the breaker. So I'm ensuring that if my CT is after the CT after the breaker, CT will look towards the protective equipment. In case of the feeder line would be the protective equipment. In case of the transformer would be the protective equipment. So the CT will if any fault happening between the breaker and CTR breaker terminal, so that fault really not going to issue the trip command to remote substation. This is what I have mentioned here. So when any fault on the feeder occurs, both sides of the feeder protective relays are operated as both substation relay communicate with each other. I'll come on the communication method also in today class, like wave trap and then PLCC and then FOTE, OPGW. These are the communications method. So when any fault on the feeders, both sides of the feeder protective relays operated as both substation relay communicate with each other, and both side circuit breaker get an open command to isolate the feeder from both substation. Am I clear with my statement number one? Statement number one. So
Yes, sir. Yes, sir. Yes, sir.
I given the three statements. Statement number one, breaker CT just after the breaker. I wanted to reduce the conductor length which the short circuit current will travel or will cover. Point number one. Point number two, I wanted breaker terminal fault under bus bar zone fault. Uh, Point number two. Point number three, I told that when any fault happened in the line way, in any line, so both relay will sense the fault and both breaker will isolate this line from this A and B. Both substation will isolate this line. Will isolate the line. So if the CT is before the breaker, like this is the case, CT is before the breaker here. Breaker, this symbol is for the breaker, this symbol is for the CT. CT is before the breaker. Then circuit breaker will be under the feeder or line protection zone. Then breaker would be under the line protection zone. If any fault occurs at the breaker terminal at opening or closing time, are between the breaker and CT, between breaker and CT. So take this case, take this case, take this case. If any fault happens on this circuit breaker, or if any fault happens between the CT and CB over here, if any fault is happening, if CT is before the CB will be under the breaker will be under the line protection zone. If any fault occurs between CB at CB terminal or between the breaker and CT, then that fault will be considered under the feeder protection zone. Due to this, the remote end substation breaker will incorrectly trip even if the fault occurs at the local substation, and the feeder will be isolated unnecessary. So therefore, it is recommended that the CT should be installed after the breaker. And I have given the three reasons. Means two reasons I can say, two reasons why it is like that. Am I clear on both the reasons for AI substations? Am I clear? I'm trying to tell you why CT you are placing over here. Why not over here? When you are making the single diagram, when you are making the FLD, yeah, when making the single line diagram, sequence of equipment interconnections should be clear. So in that point of view, I'm taking this topic. Okay. Now let us see about the GIS and what is their practice usual. So in GIS, there is two practice. The practice number one, I have taken a snapshot of the GIS SLD. Here you can see, right? LIU for line interface unit for the photo. This is communications. Okay. So do not bother about this. So here, if you see, this is my GIS SF6 to air bushings. This is my here duct here, right? Dotted and indicating GIS. So below here GIS and after this AIS. So in this GIS also breaker is after CT is after the breaker, but there is one more approach also followed. In that approach, the CT placed on both sides of the breaker. Could you see this? I took the snapshot of a GIS model. Could you see? The GIS is our separate model. In that we will discuss GIS in the detail. But just to take the CT point, I took the GIS here. could you see this the longest module is the breaker module. So could you see this horizontal module of the GIS? This is the breaker module, breaker operating mechanism box, all this white color as you can see here. And this is my CT. So in this particular case, CT located on both sides of the breaker. Am I clear? This drawing is clear. So why they do that? And now second you can I think here you can share your experience.
Yes, sir. Means on my experience, like mostly the CT which is before the breaker looks for the line protection, and CT after the breaker looks for the busbar protection.
This one, right? This one.
Yes, exactly. Yeah, like this.
Yeah, I have taken the point here. So the CT installation practice for the GIS is same as the for the AIS, but sometimes I am telling sometimes because this is not every time. Sometimes some client they have few other practice for the CT. The reason is that why? Because GIS is very costly equipment. They do not want to compromise with the GIS. It is very expensive. Maintenance is very time consuming. Outage time is higher. Outage time is higher in GIS compared to AIS, right? Because you have gas, so you have to degas and then fill the gas. A lot of activities involved when the maintenance comes for the GIS. So they wanted to protect GIS more than the line side protections. So few company, but not all. But sometimes in GIS substation, a few companies install CT on both sides of the breaker. Why? There is a reason. There is a reason why they are doing that on both sides of the breaker to avoid the blind zone between bus bar and CB. Avoid the blind zone between the bus bar and CB. As once the CB is closed, then only the line CT can sense that fault. Means in case of the GIS, this system is little bit complicated because in the AIS between the bus bar and the disconnector there is enough adequate space available. But when it comes to the GIS, this is very compact equipment placing, and my disconnectors like is exposed for the VFTU, very fast transient over voltage. It is exposed to VFTU between bus bar and the disconnectors and the like breaker. This model is very much complicated. So what they are doing, that they are, if any fault occurred, suppose this disconnector is closing, right? This disconnector is closing. Since the spacing is very much less, very less space between the, this is my 220 kV or 400 kV bus bar, right? Here I have 0 voltage altogether. Spacing is less, spacing is adequate here, right? Very less spacing. And then we are closing this switch, right? There would be the higher transient over voltage during the disconnector closing. And if any fault happened between the disconnectors and the CT, between the disconnector, the breaker, that fault will be under the blind zone unless my breaker is not closed and fault not reached to the CT. This CT could not sense those faults. So to avoid this blind zone, to avoid this, what few company putting, they split the CT. That Astekar is telling, split the CT. What mean by the split of the CT? That here I'm taking suppose 5-pore CT that generally we take for the 220 kV or 400 kV transmission line level. So like 2 core for the line protections, 3rd core for the metering, and then 2 core for the bus bar protections. So this CT, my S1, it is going like that. This point I will take, not this point. This, it is looking over here. This again looking over here. This is my metering core, and this core, now this last will look towards the bus bar, towards where the city looks. In that direction they will protect the city looks. So what I'm doing, this is what the general practice that we will do. I'll come on this core allocation as well. This is we'll discuss in below slides. So what I'm doing core splitting, means out of 5 core I'm putting 2 core over here. This is what you are trying to tell, right? Astika, 2 core or 3 core, I'm putting 2 core, right? Not 3 core, 2 core.
Exactly.
2 core
Yes, sir.
putting, 2 core putting there, means let me draw again this single line diagram. This all things I'm discussing in the SLD point of view. My CT sizing calculations has been discussed, but this is for the SLD point of view represent. So 2 core putting above the breaker, and then 3 core putting after the 2 core before the breaker, and 3 core after the breaker. This is my core splitting that I'm telling. It means there would be two different separate city, right? As taken two separate city, right?
Yes, sir. Exactly.
And then
Yes, sir.
this point, this now again I have the choice that in the AIS this is my choice for the core allocations, but here I'm my choice means whether which core should be the bus bar protection zone core and which core of the city would be the line protection zone core. So suppose I'm following like that, means this core for the bus bar, this core for the bus bar, this core for the line, this CT core for the line, sorry, and this is for the metering purpose. So what will happen? Here will be the blind zone, right? Correct, no? Blind zone means
Yes, sir.
this particular piece of circuit is unprotected, that I'm telling as a blind zone. A piece of the circuit, it is my blind zone here, blind zone created here. So this is not desirable. Protection overlapping is good, but protection unprotected is not good. Blind zone is not good. So what we do, that this two core, instead of assigning for the bus bar protection zone, we assign for the line protections, and this 2 core which is in the last, that core we assign for the bus bar protection. So here I will get the protection overlapping, right? Am I correct?
Yes, sir.
This, see, others who are not in the protection,
Yes, sir.
if they're not able to connect with me, do not worry at all. Protection is my separate module, separate topic. But so these points, they just note down in their notebook if they're not getting understand. When I will discuss the protection topic, and then they can revisit their notes, and then they will easily understand what they have written without understanding. They can easily reconnect there. So this is what we are doing, the core splitting here. So if you company CT install CT and both sides of the breaker, so this is the like figure that we have, this figure. On both sides they are installing. Due to that reason, here CT you can see on two sides. To avoid the blending between the bus bar and the CV. As once the breaker is closed, then only CT can sense the fault that we discussed. This ensures that any fault that may occur within the GIS are immediately detected. CV also has duplicate protection or overlapping protection zone and may trip instantaneously. So blind zone can be avoided. In GIS, the disconnector operations lead to the VFTU. VFTU stands for the very fast transient over voltage. This precautionary measurement, putting CT on both side of the breaker or splitting the CT core, reduce the risk of burn through in GIS module. The burn through in module caused by burning or arcing as the SF6 gas lose its insulating property due to burn through. So I wanted to avoid any kind of the burn through, or I do not want it to put or leave any blind zone inside the GIS. So even though if my line unnecessarily tripping, that can be tolerable, but with the GIS, SF6 insulating property, they are not tolerating. Am I clear with AIS? With GIS, in GIS, two approach. Some company follow this method, same as AIS. Some company follow this method. They are taking that approach. Am I clear with both? I'm telling the approach means I'm putting the CT like
Sir,
that.
SF6 burning. Could you please re-explain the SF6 burning and that thing? I didn't get
We
it,
have
sir.
GIS, we have a GIS model. In that, I will come on. Do not pull towards the GIS as of now. Let us stick through the CT. I'll come
Yes.
GIS. I have a separate model. I'll discuss during that.
Okay, sir. Thank you.
So here, if you see model number 3, transformer SLD. So I'm discussing SLD point of view because the objective of the model 2 is the equipment selection, sizing, and sequence of interconnections for the SLD purpose. So in that point of view, I'm discussing, and thereafter I have a SLD for gas insulated substance. So in that I have a detail. In syllabus, I have written very much less, but I have a detailed study for the GIS. So I will take that point over there. And then after that, I have the protection, which we will discuss in detail. So if others, if they're not able to understand, do not worry about that. Okay, except the burn through, that is clear. CT in
Sir, I have one doubt.
yeah.
Sir, in AIS, you have said that CT is placed after CB, but I've seen in SLDs, the line which is connected to bus in that section, CT is placed before CB, and the line which is connected from bus to transformer in that side,
This one,
CT
this
is
one,
placed
this
after
one,
CB.
this one, this one you are telling.
Yes, yes, yes.
See, start from the bus. Look from the bus side. This is the like your reference point. You look, your reference point is the bus bar. Okay, Vishal, you look from that point of view. Let me take
You are
both.
only taking the section which connect
I'll take
main
both.
line to bus.
I'll take both. Just one second. Yeah, now here I have the bus bar, Vishal. Okay, right?
Okay.
Your reference point is the bus bar. So here you have disconnector over here. I will discuss disconnector in the next coming models. After that, you have breaker, right?
Yes, yes, sir.
And after the breaker, you have CT over here, right?
Okay. Yes, yes.
Coming to this is my transfer module. Oh, I forget to cover the transfer. Here I have the transformer, right?
Yes, yes, sir.
Again, I have the bus bar, then breaker,
Mm,
and then CT. Like that, na? Breaker, then
okay,
CT.
okay, okay. Okay, okay. You referred bus bar as a reference, and from that you have taken the section. Okay.
Yes.
Okay, understood, sir.
And I told you one statement that CT towards the protective equipment, right? CT towards the protective equipment side, right? Correct. So here in this case, what is my protective equipment? Transformer.
Yes, sir.
And here in this case, what is my protective equipment? Line by.
Line base.
So CT towards the protective equipment, right? This point also satisfied. CT towards the lines,
Yes,
CT towards the transformer.
okay, sir. Understood.
Okay, okay. You understood, then I'll go to the next topic about the CT when it comes to the HD panel. In the HD panel, here I took a snapshot of the HD panel. This is my outer view, but how it looks like internally. So here we have the bus bar. Then here we have the vacuum circuit breaker VCB, right? And then here we have the cable chamber, which cable is coming over here. So after that we have the PT, and then we have the CT. So break incoming cable CT, and then going to the breaker, right? And then going to the bus bar, correct? Isn't it? Could you see this HD panel?
Yes, also the AC is there.
So CT,
ICOG, sir. ICOG, I think.
CT after the breaker. Why? To test the CT, because in panel you don't have the free movement. You don't have, right? And if you're putting the CT after before the breaker, it means you are putting CT near to the live bus bar, right? Which is not desirable. You could not test the CT in that case. So to test the CT and CT connection, it is preferred to locate the CT on the load side or after the breaker. That also we can say, or we can say on the load side. This allows for easy access by simply opening the racking, simply opening this breaker chamber, rack out the breaker or draw out the breaker. So once you draw out the breaker, what happened? Your CT isolated from the bus bar.
Yes.
And then we can do testing or any connection at the CT. So this is again preferred to place the CT after the breaker. So if the CT is located on the bus bar side, means before the breaker on the bus bar side, this is not possible to test the CT, and the entire bus bar must be shut down. Take this statement, go to the SLD. Here I have the SLD of 33 kV feeder. Could you see here? I have the breaker. This is output. Due to that reason, disconnector is coming here, but you forget about the disconnectors. So bus bar, breaker, CT, and then line bay. So this concept is applicable for this 33 kV or 11 kV feeders. Am I clear? The CT locations for the HD panel, CT location for the GIS substations, CT location for the AIS substations for SLD preparation point of view.
Yes.
And coming to the polarity, CT polarity means this P1 P2 marking. P1 P2 marking. This is a disputed or open point. So what I'm telling, this is not universally accepted, but I'm telling that what is the most industrial practice. So P1 and P2 about this polarity, orientation of the polarity, that how we will place the CT, right? Means if my CT is over here, so how I'm going to place P1 terminal would be here, or P1 terminal would be here, or P2 here, P1 here, like that. This placing, it becomes important. Like so when you have the CT, I'll show you a CT equipment drawing, CT equipment drawing. Like here, we'll take any equipment drawing. CT equipment over here, CTPT, CVT, and let us take this CTGA drawing. Okay, CTGA drawing. So when this CT reach at the site, okay, which selection sizing you are doing over here, you see here we have the P1 and P2, right? This is what we are discussing, this CT. This is in the circuit, but at the site, it would not be like circuit. It would be like this, correct? So now your site engineer, your erection engineer, where they will place this P1, whether breaker site or the line site, and whether they will place this P1, P2. This is also a important point that need to be taken care when you are making the single line diagram. So this point of view, so my discussion is this point of view, this P1 and P2 point of view. Again, this is a open point. So what I'm telling as per the industrial practice, but client confirmation is Samsung grid. So it is essential to define the position of CT polarity or orientation of CT polarity. Polarity, I mean P1 and P2, this is the polarity in single line diagram. It is essential, means it is must. It should be defined. So in industrial practice, the P2 polarity is oriented towards the protection zone. Industrial practice, I'm telling, the P2 polarity is oriented towards the protection zone. Our protective equipment site, for example, for protective equipment site means it could be a line feeder bay. So P2 will be at line site, and for the transformer feeder bay, all CTs, why I'm telling, because in the line, in the transformer bay, I will have the HVCT, LVCT, and neutral CT, right? Isn't it? For the transformer, we have CT, right? Could you see P2 here? This is P1, P2 here, but this P2, it would be good if this P2 is placed over here. So P2 here, again this P2 over here, means all this CTs P2, or if you're taking P1, means all the polarities should be on same side. So P2 over here, P2 over here. This P1 is indicated here. I'm not sure why they took like that, but it would be good if P2 is coming over here. This is an open point. So like if anyone want to share their experience, they can like unmute and
Flow up current, sir. Flow up current. The basic thumb rule in transmission is P1 should be always towards bus side. This is the thumb rule. So while commissioning the CT, we always follow the rule P1 towards the bus side.
P1 towards the bus side. It means P2
at any location of the city, any place of the city, P1 should be towards the bus side. That is the thumb rule.
Yeah. So yeah, breaker over here, and then CT coming over here. CT have the polarity P1 here and P2 here, right? So you are telling P1 on the bus side, correct?
Always.
Always.
For HV, for LV, for any connection, for TBC also, P1 should be towards the main bus. P2 should be towards the auxiliary bus.
Line. Protective.
Yeah, P2 towards line. Yes, this is the thumb rule.
Yeah. So why that thumb rule is established the flow of current?
Sir, can you show that SMT versus
for uniformity and for protection, simplification in protection also.
Uniformity, simplification of the protection of the grid operator, that whatever their uniformity. So the grid operator want to keep polarity uniform, right? Like that.
Yeah, and they will always means check and cross check the connection like in this format only.
in this format, P1 bus and P2 line, right?
Yes.
Okay. So yeah, that's why I told you this is grid operator. They will take care of. They will ensure that. So yeah. So sir, as you told, in the similar way I have put in my presentation as well. P2 is polar. P2 is oriented towards the protection zone or protective equipment side. For example, for the line P2 on the line side, for the transformer P. So so sir, what is your opinion on that? Is that okay? It should be reversed. P2 should be here.
No, it is correct, sir.
The reason?
It is correct. P1 towards
Actually, bus means source, I think. In this case, transformer is the source.
Yeah.
Those are, sir, those
Can
are
you
neutral
scroll down
cities.
a bit? Can you scroll down a bit, sir? No, just shrink. Again.
Sir, those are turret cities, right?
No, this is NCT, and this is NCT, neutral city of the transformer.
In case of neutral city, P1 should be towards transformer and P2 should be towards earth
Grounding.
point. Yes, ground.
The reason, because transfer is the source.
Yes.
So you are following the similar rule. P1 is on the source side.
Yes, sir.
Hello.
Yeah.
Could you please explain the neutral city?
I'll come on that, Noor Jahan. Hold on. I have not come on the neutral. I'll come on that. Give me a time. But let me complete first the polarity.
Sure.
Okay.
Sir, this might be this case that if any fault is happened at the neutral conductor or the start point, then the current will flow towards the ground. No, that is the same P1, P2. It is the same scenario.
Okay.
So why you are thinking that P2 should be towards the transformer? At the starting, you are saying that it should be the opposite. Can you share that?
No, come again, Dennis.
Sir, one more question.
At the starting of this discussion, you have said that P2 should be preferably at the P1 and did the vice versa for the neutral city. Do you have some opinion on that?
Sorry.
Yeah, Dennis, come again. Your point is not.
I didn't get the question, sir.
No. Raghav sir has told that for the neutral city, the P1, P2 should be reversed one.
Yeah.
So I'm not getting that. What was that concern?
Actually, I told in a few SLD preparations, I try to keep all the polarity uniform and towards the equipment side. So here P2 I took on the transformer. For the LVCT, P2 I took transformer. So I thought there would be a chance that this polarity could be changed and this P2 will come on the transformer. Due to that reason, Dennis, I told. So this is
okay,
this is one way. This is one way.
In addition with that, can I add something?
Yeah, yes.
If you look a bigger picture, neutral cities generally, turret city and neutral city generally we use for REF protection, restricted earth fault protection.
Correct.
And in series of REF, we use stabilizing resistors.
Correct.
So if you draw the bigger picture, the current should flow from that stabilizing resistor before flowing through that relay. So that's for that reason only we place P1 towards transformer and P2 towards neutral or ground.
Okay, sir. Okay.
Sir, P1, P2 is linked with the core distribution. Hello.
Yeah.
Sir, this P1, P2 is linked with our core distribution. It's like this every
Yes.
4 core 3.
Yes. Link code distribution as well. I'll take that point as well. Yeah. So all city P2s. Okay, coming back. So I think this point, the statement is valid in like other utility case as well. So. Okay, I'll take some. Let us discuss the last time. So, for example, line P2 is at the line side. For the transformer feeder, all P2 shall be oriented at the transformer side. And the CT star connection, this is another important point as well. The CT star connection made to the protective equipment side at the substation, inside the circuit. Current transformer junction box are inside the control and relay panel. So I took here a star formation. So if you see here, I think this topic we have discussed earlier as well. So I have the CT. This is my, I hope this circuit we already have discussed, so it is clear. But just a small recap. So L1, L2, L3. So R phase, Y phase, and B phase. So CT here, P1, P2, P1, P2, and P1, P2. P2 is towards the protective equipment side. So all P2, so all the CT, this core, we will extend from the CT core. It will come on the CT secondary box here, right? Like if we go here, if we go to the here, so here we will have the CT secondary box on the bottom of the CT. Could you see here this one?
Yes, sir.
Yes, sir.
This one. This is my CT secondary box. CT secondary box. So all this core formation that we are discussing, so all the S1, S2, S1, S2, S1, S2 core, we extend till CT secondary box, which is placed over here. And then from that CT secondary box, we take the cable, and that cable, through that we extend till CT junction box. That CT junction box we place on the middle phase or on the Y phase. So from R to Y, from B to Y, we have to place the cable. And in the CT junction box, all S1, S2, all phase like R phase, Y phase, B phase is coming. So we'll take core one, all the three phase core one we took, and then their P2. So on the P1 side would be S1, and the P2 side would be the S2. So like P2 side, S2 secondary 2, primary 2, secondary 2. So all the S2 of all the three phases, we connect, we interconnect, and then we connect finally to the ground. This is called the star creation or star formations. And S1, all the S1 from the junction box will connect to the control and relay panel. So R phase, then Y phase, and then B phase, and then from that star point we take as a neutral point. So this is how this polarity and CT connected with the control relay panel. So again, I'm putting here one disclaimer line. However, the grid operator company will take the final call, or will decide, or will approve the final polarity orientations are P1 and P2. But this is the like usual or industrial practice. So 90% case we follow this kind of the practice. But again, I'm putting that do not stick and do not form with this P1, P2. If grid company have any different set of practice, so they will decide that they will approve your P1, P2 polarity. So no need to fight that this is not correct, or I have given some other informations, then you are facing some other information. So and P2, you follow the grid operator company and their usual practice as well. Hope I am clear with the P1, P2 and the CT to CRP, their connection, and CT secondary formation towards the equipment, prototype equipment side.
Sir, I have doubt. The CT polarity also depends on the current direction also, because I heard from someone, they said ki CT polarity P1 is placed on the source side from where the current is coming,
Yeah,
and the
same
P2
we
is
discussed
placed.
this. Same we discussed. P1 on the source side. Source is bus, right?
Okay, basically it is based on the current direction.
Yes. Yes. Yeah. Okay, Visa.
Okay, sir.
Okay, and now let us discuss about the core allocation, about the core allocations. So once the P2 polarity is on the line side, then P1 polarity will be at the breaker side or the bus side. And in multi-core CT, the core counting start from P1. So the core which is near to the P1 will be core 1. Means in that case, if I take this snapshot, if I take this snapshot, so if I'm putting P2 on the line side, P1 would be automatically on the bus side, breaker side. So if P1 is here, so this would be my core number 1, core 2, core 3, core 4. And if I'm using the 5 core cities, that would be the 5 core. Where we use 5 core city, 3 core city, 2 core city, this topic we have discussed module number on class day 12, right? Day 12 or day 13, we have discussed about that course number.
Yes.
So standard industrial practice is that the last core to be assigned for the bus bar protection zone. The last core, this core will be assigned for the bus bar protection zone. Is the last core to be assigned for the bus bar protection zone to avoid the blind zone inside the CT conductor length. Means if so this CT need to protect. First of all, we need to understand CT to which they need to protect. So in this case, if I take the substation in a wider point of view, so in substations we have the three like major circuit. One is the line circuit. Second is the common bus bar circuit or common bus bar, and then we have third the transformer. So all the substations basically is made through that. It could be line 1. So this is my protection zone 1 line. Protection zone will be bus bar. Protection zone will be 3. So majorly we have 3 protection zone, right? And this bus bar protection zone is common outcome of the line protection and the transformer protection. Means both CT will interconnect and they will be connected to the bus bar differential protection, really, right? And this work on the Kirchhoff current law. This we will discuss in the protection model. So it is their topic. I'm just taking this topic briefly for the CT core allocation. Is it clear to others who are in the subsystems? They know about this. Others, they please note down. So my 3 protection zone line bus bar transformer. My bus bar is the common outcome of the line and the transformer protection zone. So it means when I'm placing the CT, so this is my, if this is my line bay, so this CT need to protect the line and this bus bar, the bus 1 and bus 2 here. So now I'm using CT. So if we have like seen that when the line voltage level is higher, so we have the backup or duplicate protection. So this is the case. This is the case for the 132 kV. This here we have the case because we have distance and then directional overcome. So this is the 132 kV. Up to 132 kV we take this protection philosophy. So here core 1, this is assigned for the line main 1 protection. Core 2, this is assigned for the line as a backup protection. Core 3, that would be just multifunction metering purpose. And core 4 and assigned for the bus bar main, and core 5 is the assigned for the bus bar check. Main check means main and backup. So here the standard practice is that last core should be assigned for the bus bar protection and the first core should be assigned for the line protections. Why I'm doing this method? Because I wanted to avoid the blind zone which is happening between the CT conductors, means CT here. So from this conductor, from this core to this core, there is certain a piece of the conductor length, correct? A piece of the conductor length, right? That would be very small, but that will exist. So what I'm trying to do here, that if I'm not placing CT like that, I'm taking the second case. If I'm placing CT like CT here, core 1, core 2, core 3, core 4, and core 5. If I'm placing CT, this core 1 would be bus bar protection zone. This CT is my bus bar protection zone. This CT is my line protection zone, and this CT is for my line protection zone. So this much small piece of the conductor is coming under the blind zone, isn't it? Is it making some sense? Is that making a sense?
Yes, yes.
So to avoid this blind zone, how we allocate the core, that we take the CT, core 1 is for line, core 2 again for the line, core 3 just for the metering, core 4 and core 5 is for the bus bar. So instead of creating the blind zone, I am getting here protection overlap. Means the blind zone is avoided. Here no any blind zone. Am I clear with this point? So standard practice is that last code to be assigned for the bus bar protection zone to avoid the blind zone inside the CT conductor length. The bus bar diffuser protection zone can cover the circuit breaker fault under the bus bar protection zone fault instead of the line protection zone. This already we have discussed. So this is my, now let me come back to this single line diagram thing so that it will be clear. So coming to this SLD back. So if you see here, so after CT here, just after the breaker, this point is clear. Now this is P1 here, P2 here, P2 on the bus side, already we have discussed. So this CT location is clear, polarity is clear. Now I told that secondary star point towards the protective equipment. So if you see here, this is P1, this would be core 1. So this would be my S1, right? This would be my S2. Correct now?
Yes, sir.
Right, right.
So S1 going to relay, S1, all the S1 going to relay, all S1 going to relay. So S1 will like decide your view where you are looking. Means if I'm taking S1, it means I'm looking S1 onwards. Here, like just a like approach. So S1 up onwards. So S1 here, it means S1 in this way I'm looking. S2 I'm making the star point. If S1 I'm making the star, suppose S2 I'm taking the relay, it means I'm looking in this direction, right? Correct now?
Correct.
So make sure when you are making the single line diagram, you take S1 here, S1 here, S1 here, but for the bus bar, since you are looking reverse, you are looking towards the bus side. So for this core 4 and core 5, take the S2. This core, not this one. This core, not this one. I'm trying to tell here that here I took this, but here why I did not take this? Why I took this? Why I took like this?
We have to protect the bus.
This is what
Fuel
I'm
jacket.
yeah, correct. So this is what I'm trying to cover. This the line that you are extending. This which line you will extend during SLD preparation. Again, note down SLD preparation. here is the snapshot. So S1 here, this line extended, this line extended, this line extended here. But ideally, this is not this metering, there is no protection zone, so any line we can extend, or we can take center tapping. So here, the last one, here the last one.
So actually, that's the side of the secondary, no, not the
Yes,
core is same.
yes, side of the second.
Core is same.
Yes,
Yeah.
yes.
So that means the side where we make the star point is getting changed when it's changing from bus bar protection to line protection.
Yes, yes.
Okay, so thank you.
Yeah, any other opinion on that? Any other opinion? Sheikh sir, what is your view? What is your thought on that?
Sorry, sir, I don't get.
About this, no, that we discussed. This line, the line that we extended.
Correct, sir. About that star point of S1. So we are looking towards the bus bar for protection. That's the main standard procedure.
Yeah. So we need to extend this line.
Yeah, we need to take S2 for bus bar protection and make a star point of S1 so that it will look towards the bus.
Yes.
And those S1s connected to the bus bar differential protection, simple Kirchhoff current law, in and out. So it will make a smart protection.
Correct. And when it comes to the line protection, so we take S1.
We take S1 from CT and make a star point of S2. So our distance protection and directional and non-directional overcut asphalt protection should look towards that side.
Yeah. So
line side, yes.
Correct. I hope I'm clear with this. This all discussions, please make sure I'm telling that when you are making the SLT. So small point, the minor point is very important. So enter into the minor to minor detail depth. This is what I'm taking. Otherwise, from my Salvage point of view, CT sizing I have covered, finished. But again, just to tell each small means P1, P2, which line extend this one, which line you will extend. This all is the minor to minor point.
So, in the SLD, the unextended line should be grounded, which means that it can say which star point is going to be protecting.
Grounded, yeah. So if there is spare core, that you make it grounded.
Yes. So basically, it shows the towards a protected object where you are going to protect.
Yes. Now I have one. So I have covered now the protection CT. I have covered now the protection CT. There's this CT, this CT, this CT. Their like ratio and selection, and for different core, what is the different rating we decide that all selection that we have covered, their location of the installations, their polarity orientations, and the star point creation. This all we have discussed for this protection CT. Okay. So now I can say that I have touched like most of the point for the protection CT, right? Not the designing point of view, but the site, few extent for the site point of view as well. Now, if you see the single line diagram, we have one more CT. This CT. This CT is the terms is dedicated metering CT. I have a dedicated metering CT and metering BT. Where I should connect this and where I should not connect this. Where I should not connect this, or where it is mandatory, where it is not mandatory. So the point is that in generation power plant, most of the generation now is the renewable based. So I can say in renewable power plant substation, we have a separate dedicated tariff metering CT and VT that you can see here. I took the snapshot for the line, and where not everywhere it will come in the line way only. The line way from where you are evacuating all the power and feeding to the grid on that line way. This dedicated metering will come for the line feeder way in addition to the protection CT that we discussed so far. For the precise revenue metering via the ABT meters, availability based tariff meter is the a full form of the ABT meter. So in addition to the protection CT, for the precise revenue metering via the ABT meters, the DISCOM, most of the time we hear the word DISCOM, we can say DISCOM stand for the distribution company, which is in short we call it the DISCOM. This means distributions com is company. So DISCOM, DISCOM is a distribution company by the government. DISCOM, the DISCOM will ask to place the dedicated metering CTVT towards the line exit site for the precise energy metering purpose, and wants to save the conductor length from the point of metering, and there needs to be a metering cubicle for the DISCOM reading purpose. Means CTVT placed here, CT and VT, we take 2 core CT and 2 core VT, and after that we have ABT main meter and check meter. That meter we place in a metering cubicle. That metering cubicle should be placed outdoor, not in the control building, outdoor near the tariff CTVT, and that metering cubicle will be logged by DISCOM engineer. So that metering cubicle meters CTVT all sealing done by the DISCOM engineer, because this is the property of the DISCOM that you are placing in your substation premises. Why? For the precise revenue metering. This is the property of yours. This CT is the protection CT. Most of the core is for the protection purpose. Just you have one core for the metering purpose, and that metering will come in your control building. Am I clear with why 2 I'm taking?
Yes, sir.
Metering cubicle for the DISCOM metering. This metering CT ratio selection concept same as the metering core of the protection CT. Just the difference is this ratio must be as close as possible to the maximum of feeder current rating, and shall be or must be 0.2 S class accuracy. Means this, now you can see here, this is a 300 megawatt solar power plant, power evacuating at the 220 kV level. So you can see what is the CT current ratio. Is it correct? Could anyone calculate and tell me this rating? The metering CT, VT are not discussed, I'm not coming on the VT, but CT is it okay? 300 megawatt on 220 kV.
Correct, sir.
787 means 800
Yes.
amperes.
It's a standard 900 ampere.
900 is the standard, so I can go. I took the 900 CT, but I can take 800 also. There is no problem if 800 is easily getting in the market. Okay, let me take the another example. Here, this is a 70 megawatt solar power plant.
And they can, I'm sorry to interrupt, sir.
Yeah.
And they cannot take 800 exactly. And the power factor also will take a major role, right?
Okay. Yeah.
No, just I want to say, full load current itself coming 780, we cannot take out 800 because power factor also will matter. Even though if we consider a 0.9 power factor, the ampere will come close to 880 ampere. Just I want to add here.
No, it should be close to that 900 ampere. 900 ampere as a standard, but this is a solar or in solar or wind generation there is a major difference. In solar power plants the power factor does not play a vital role. It nears to
I
1.
understand. I'm just giving a justification why they are not given 800. Instead they went to 900.
Actually, it plays a it plays a role.
That's the problem about manufacturing. They manufacture 900. They have designs. To make a 800, they have to make a separate design. It may increase the cost also. That's why.
No, that is okay. That is the standard design 901. That's not an issue. But still, we have to consider the power factor for this one, since we are using the
that's what I want to
using the instruments there. That is inverters. So inverters have the lagging power factor, and even the PV cell doesn't come with the unity power factor. There are certain things we are getting the PV cells with the 0.96, 97. If you go with the ISH and like that one, no, then we have to check it. Raghav sir, correct me if I'm wrong.
No, okay. Yeah.
Raghav sir, I have to add one point regarding this one.
Yes.
In the case of solar power evacuation, normally depends upon the client requirement, because they never need a unity power factor load. For that one, they normally require 0.92, in between 0.9 to 0.95 or 0.98. They will demanding the power at a power factor of 0.95. Normally they are asking. When we are providing the power at 0.95, then there will be a calculated current of 828 ampere. Mostly that may be a reason for selecting 900, because unity power factor, all the power producers are supplying the unity power factor that will impact the grid. That's why they never need a power of unity power factor.
It has to be in the lagging only.
Yes. It has to be mostly it has to be in a lagging.
If any load is going down, no, then the power factor is going to lead. That's why they require 0.99 and 0.98.
Yes. Yeah.
Yes,
Inverter normally inverter has a capacity to minus 0.82 plus that is the variable range. That is a variable range, but that depends upon the grid requirement.
Yeah, we have to keep
that. Yes, right.
Okay, anyway. So, see, whatever the city you are taking, they have 120% extended capacity, okay? Like who asked the query about 800? So I'm taking 800, you don't worry about that. The same city could deliver 120% extra.
That is one of the reasons.
Okay. So don't worry about that. Yeah. Let us take this one. This part. Let us see here. This is 70 megawatt solar power plant. Power evacuations at the rate of 132 kV to grid services. Here, if you see the protection city, let us first see what is the ratio. 600, right? 300 multi ratio city, multi-core city. Now here the important point what we discussed so far. Important point. The star creations. I'll come on that. But the star creations, I think you can take reference of this SLD as well. The star creations right here.
Yes.
See P1 I have changed the polarity here. This is my line here. This is my bus bar here. because this polarity was not clear in the beginning, so we have marked it randomly, but I'm not sure that is it which revision point, but when it will be updated, this polarity will be like P2 here and P1 here. Okay, but again, this we do not finalize, and we discuss with the DISCOM or the client or the GSS that what is the remote end substation polarity. Accordingly, we keep this polarity in case of the GI solar power plant. Okay, am I clear? Statement number 1, because this P1 is here right now. We discussed P2 should be on the line side. So this is I'm providing clarifications about this. You can see the star point here. Here, this is my sphere. Okay, Dennis, you sorted and grounded.
Yeah.
You asked. This is my line protection. So I took this for the line. Grounded. This is my metering. So I took this middle point. But I do not take middle point. Take the S1 point. This one. Here, no problem. Anywhere we can take. But this is my line protections over backup over current. So S2 here, right? Sorry, in that case P1 here, so S1 would be here, S2 would be here, S2 would be here. But yeah, the star point I'm making towards the protective equipment, So protective equipment is the line. So the star point is my towards the line here. Here, this is for the transformer. T70 is the transformer. This was line come trafo way. So due to that reason, bus not coming, trafo coming here. So star point I'm making towards the transformer here. Okay, this is what we discussed for the potentiality that I just extended that discussion for this SLD extract. Now coming on this metering CT, if you see here, my potentiality have 600 ampere code. It could be, there is no problem here. 600 by 1 is okay, acceptable, right? And which tab we select, below that tab we do the underline. So here 600 tap is selected. That's fine because this CT utilizing for the protection purpose, right? So there is no problem here. But when it comes to the metering, the CT would be precisely, ratio should be precisely selected. So now for the 770 megawatt, what is my current coming?
306.
And what is the CT ratio here?
306.
350.
350. Yes.
It is very much close. So 350 is okay.
Yes, sir. Right.
So due to that, I'm telling here that the difference metering CT ratio should be selected. Metering and in the metering CT, in the protection CT, the difference is that the metering should be metering CT current ratio, turn ratio should be as close as possible to the maximum current of the feeder. But in case of the protection CT, it is not mandatory. We can take like 150% margin, we can take 200% margin. It is not so much like important, but when it comes to the metering CT, it is very much important, right? I hope I'm clear with the with the metering CT current ratio.
Yes, sir.
CT current ratio.
Yes, Raghav, sir. One doubt.
Yeah.
Sir, in the case of metering CT, in protection CT, the metering core star point is you have marked towards the line side. Okay.
Do not worry about that. You can make a star point because that is not looking for the protection. This is just
okay, sir.
Now I wanted to take one more additional country, their engineering practices. I took the example of the UK and United Kingdom. So what they will do when they will make the single line diagram, in Asian country, we have this practice, means we have a separate CT, separate VT. But when it go to the United Kingdom, UK, they do not prefer to use separate CT and separate VT. for the metering CTVT. They have a common equipment, and that equipment indicate in SLD by this symbol. Could you see this symbol? The yellow marked here. In a same CT, in a same seat, in a same equipment, the CT and VT both combinedly placed. So this is called the combined instrument transformer, combined CT-VT. In the UK, the national grid also used the dedicated tariff metering CT and VT when any generating power plant connect to the grid substation. But there is a difference in Asian country. They use the separate CT and VT, whereas in the UK they use a combined CT and VT, which provide a land savings in the substations. Means they can save the land of the substation area, and they go with the CT-VT. I took this SLD example because sometimes during the interview, at the time of the interview, they will show their SLD and they can ask to read the SLD. So how you will read the SLD and how you will make the understanding which symbol is representing what equipment. So this symbol representing the combined CTVT. This symbol is disconnector or isolator, same as we use in the Asian country. This is such as the same as we use in the Asian country. This symbol is the CT there, where it is in Asian country. For CT, we take this coil or inductive coil type of the symbol, whereas they take, instead of taking the inductive coil type of the symbol, they take just a circle. Am I clear with this CT symbol, CTVT symbol? Breaker,
Yes, sir.
bus bar. Could you anyone tell me what is this symbol?
Is it pantograph?
Is it? Yes. Is it? It is pantograph type disconnector with earthing switch and the earthing. This simple disconnector, horizontal,
Double break.
type disconnector.
What is our service?
For the disconnector, I have a very detailed presentations. In that, I have taken all the Asian and the UK practices, which is in very much detail. I'll take after the breaker. I will take the disconnector topic. Disconnector is like looks in the design engineering, in the rating calculation, it is very simple in Asian country, but when we go to the UK country, this disconnector is very complicated. I'll take this topic separately about the disconnectors. I think I have approximately 100-page presentations only on the disconnectors, considering the Indian and UK practices. Okay. Now come to the
Sir, I have one question.
Hold on.
Regarding that combined CTPT.
Yes. Yeah. Tell me now. Yes. The combined CTPT.
Yeah, sir, is there any restriction to use that combined CTPT? Like we can use at any level, even 220 kV level also they are using combined CTPT.
Even you can use 400 kV also.
Because if you are using the combined CTPT, the size will be increased and the clearance also will be taken into consideration. That's why I'm curious about. Only low voltage they are using the combined CTPT, or even though the
high voltage.
High voltage they are using.
Yeah. Okay. This snapshot I took from for 132 kV. Okay. Money?
So up to even 400 kV we have used this in our projects. Yeah.
Okay.
Yeah, so sir, the say purpose will be for protection and protection purpose.
No,
or for
metering.
metering?
Metering,
Yeah,
dedicated
that's
metering, dedicated
got it.
metering,
Got it. Got it. Yes.
dedicated tariff metering. Okay, so we discussed about the CT, protection CT and the metering CT. All those CT we connect or we place on the phase, R phase, Y phase, and B phase. Let us discuss overall about the CT type based on the locations. Means when I'm taking the single line diagram, we discuss about this CT, we discuss about this CT, but we have CT symbol like that also, and we have CT symbol here also. So what those symbol represent, what is that kind of the CT? So we can divide the CT in three types based on their location. We have three types CT based on the location of use: phase CT and the conductors, that could be metering and protection CT; bush mounted CT. Bush mounted CT means that this is my bush mounted CT, or bushing CT, or we can say the turret CT, which is placed inside the bushing. Inside the bushing, it could be placed inside the breaker if we have a dead tank circuit breaker, or it could be placed inside the transformer bushing also. Turret CT inside the transformer equipment, and when I'm putting for the transformer equipment, that mainly are basically for the winding temperature indicators, WTI. So this CT that I'm putting here, this is my pushing CT or turret CT. For that CT, we take a different kind of the symbol to represent this, and we use this kind of the symbol during the SLD preparation. This, like that, it is going this, and then it is coming like this. So this symbol that we are using. So whenever you are using the pushing CT, use this kind of the symbol. And then third, we have the neutral current transformer, NCT, and the neutral connection of the transformer. So this NCT again can be two type. This NCT again, it can be two type. It could be outdoor freestanding CT. Freestanding CT means CT is outside of the transformer. Outdoor freestanding CT, or the CT placed inside the bushing, or NCT inside the bushing, which is the case here. CT is inside the bushing. So due to that, bushing CT symbol used here. And whether it will be outdoor or it will be indoor bushing CT, that depends on the client or owner choice, which type they want to use. But the outdoor NCT has the advantage that if any fault occurs in CT, maintenance would be easy to do in the outdoor CT. But solar company wants to save the price, so they most of the time prefer to use the bushing and CT. Means if they are concerned about the pricing, so if I'm taking outdoor, so we have to make a separate civil foundation, then we have to take the support structure, and then we have to place on the CT. So to avoid the civil foundation structure, means here if you see here, this my here I have to, if I'm putting outside, so here I have to make the foundations, then I have to place structure, and on top of that structure we will place the CT. Here you see structure, and then top we are placing the CT, outdoor CT. So to avoid this civil foundations, to avoid this support structure cost, they sometimes prefer to place the CT inside the transformer bushing, but they are compromising. If any fault occurs on the CT, the outage time of this transfer would be higher. So that's why I told that it depends on the client choice, whether they are ready to take a higher outage, or they are ready to pay in the beginning and they wanted to place it outdoor. So that is the two type is availability. So based on the client concerns, we decide what kind of the CT they are looking. So if you see here, but in my SLD point of view, this is very much important. when you are preparing the SLD, you have to make a dotted line. This dotted line is represent your equipment. Means I put the dotted line like that. It means all these transformer, bushing, phase bushing CT, neutral bushing CT, LV neutral bushing CT, all the CT is part of the transformer. So to tell this, what is the mistake here? Could anyone point out the mistake? What's the mistake here? The mistake is that this grounding should be like here, right? Because grounding is not in the transformer right now. Am I correct?
Yes, sir.
Yes, sir.
So in the SLD point of view, when you are taking the bushing, phase bushing CT, neutral CT as a bushing, so please indicate this kind of the dotted line when you are making the SLD. It ensures that all the things inside the transformer. So that you see here, when I prepare this SLD and then I put or indicate a dotted line, this dotted line telling that this phase bushing CT, neutral bushing CT, LV phase bushing CT is inside the transformer. So this to make this dotted line when you are making the SLD. Bushing CT is an integral part of the power transformer. So need to tell the transformer vendor about the CT ratio and needs to use dotted line in SLD to express this is part of the transformer bushing. Right? Am I clear with the dotted line by type of the symbol and why I'm putting CT over here? So basically,
Yes, sir.
we take two core CT here. So one core for the WTI and one core we are utilizing for our REF protection purpose. One core for the REF protection purpose, one core for the WTI purpose. So two core we use in the phase bushing CT, and in the neutral CT also we take two core. One core for the REF protection and second core for the standby earthfall protection or SEF protection. Anyway, this is part of the protection model that we will discuss at that moment. Okay, so as you can see here, this is my REF protections. Here, this is spare, but that would not be spare. That means one CT core also required for the WTI purposes. Okay. Now coming on the NCT, why the NCT is required. Okay, so this is my transformer, bus bar delta star. This is my delta star grounded transformer. Star is grounded here, neutral here, HV, LV, right? The case when any line to ground fault happen, so this neutral point of the star provide a dedicated return path to line to ground fault current, and fault current flow towards the source or towards the transformer, right? So to the neutral of the star winding of transformer are grounded to establish a dedicated return path for earth fault current or line to ground fault current. This grounded neutral provide more sensitivity for line to ground fault detection compared to overall differential protection. This provide more sensitivity for line to ground fault detection and quick isolation for phase to ground or line to ground fault achieved by ground fault relay or earth fault relay, that is called restricted earth fault REF relay that we are putting here. 51N is my backup over current relay. SEF relay standby earth fault. If REF fails, then SEF will come. And by using a NCT, this sense this line to ground fault current easily and provide input to REF relay. So this neutral CT rating could be selected as equal to the phase CT. So this NCT current ratio equal to your phase CT current ratio. I intensely put this statement because most of the time I have seen that like it is not clear about CT ratio, because here at the when there is no any fault happening, so the current is 0 over here, right? Current and voltage 0 and then between the neutral and the ground, isn't it?
Yes.
When there is no fault, so when the current is 0, voltage is 0, so what kind of the current rating I take for the CT? So the preferred practice, your neutral current CT current ratio you take equal to your phase current CT current ratio, and we get a high impedance REF protection as well.
Sir, is it necessary to maintain the phase CT ratio in neutral?
Means if you are going for the high REF, so it is mandatory. Like here, if you see this neutral CT, the CT 450 and 450 or 500 both are equal. Yeah.
Yes,
Is
sir.
it the
That's
same class as?
Not necessary if you are using low impedance potential.
Yeah, if using low impedance, then not necessary.
So what about the class of the CT in CT?
See, REF would be PS class, okay?
Yes, sir.
And this is overcurrent. So for the overcurrent, what class we take? 5P20, right?
5P20.
So that would be 5P20. You can see here over here. So my P1 here, so core 1 here, core 1, C1, C stand for the core 1 PS class. And this is my core 2, which is near to P2. So that is 5P20 class.
Okay, sir. Thank you.
Okay.
Sir, one more doubt, sir. What is the position of CT, sir, NCT, other than solid grounding? If you are using star or something,
yeah.
So from the earthing point, first from the earthing point, first NCT will come, or that star resistive earthing system will come.
First, your
getting my question, sir.
First, yeah. See, first your grounding system will come. Money.
Then
first,
correct, sir.
Yeah. I'll let me take this point. So suppose here you have done the grounding, right? Grid. So line to ground what happen? Current enter into the grid, right? Grounding grid, correct? Right now, money.
Okay, sir.
Oh, you understood,
and
right?
You are placing the CT. Okay.
And this point is again grounded to the same grid.
Okay, sir. This is for solid system, sir. What if something like a resistive earthing system means? Where the resistive system will come?
The resistive system
between the CT and the ground.
Yeah. The resistive.
He is asking NGR, sir.
Yes,
Yeah,
NGR.
so first the NGR. CT, NGR, and then grounding.
Okay, then first resistive system will face the ground, then it will limit the fault current, and then relay only sends. Okay.
Yes.
Okay, sir.
Okay. Anyway, this point we will discuss in the earthing model, grounding model in the detail. Okay, Mani?
Okay.
Okay, so after that we have the VT. What do you think? Like CT, I think I have touched all the point that is required to make the SLT now, isn't it?
Yes, sir.
I think I have touched all the point to prepare the SLD for CT equipment. Okay, so I have many other points for the VT. I don't think that I will be able to finish the VT. So I'm thinking that let us discuss VT tomorrow, right?
Yes, sir. That will be better, sir.
Because I don't want to like stop in between. So VT will take tomorrow, and then open delta VT, broken delta VT, that we will take tomorrow. Okay.
Sir, I have one doubt regarding polarity. You have shown the polarity of P1, P2 in double bus bar scheme arrangement, and that we can easily as easily assign P1 and P2 based on the source side. But in case of double and bus half and
One and a half.
one and a half breaker scheme, in that scheme, how can we define P1 and P2, because the bus is on the both side?
Same concept. Vishal, same concept.
Sir, how can you explain?
I'll show you that, Brian. This is how I can explain. I was thinking about the T differential protection for 1.5 breaker scheme, 4 CT scheme for the 1.5 breaker scheme, but I was thinking that it is not too much important and it will be less in the use or sometimes used. That's why I didn't like put that point in the presentations. So, but in 1.5 we have a T differential protections. So this is 1.5 breaker SLD. Okay, Vishal, 400 kV system. Okay.
Yes, sir.
So now I have the 3 bay in one diameter. Anyway, that I was about to discuss when I was making the SLD in the module number 4. But you see here, this is my bay. This is my one bay. P1 on the bus side, P2 on the line side. Correct?
Okay, correct.
Now coming to the tie bay, P1 and P2 here for the tie bay, and then here P1 is on the bus side and P2 is on the load side. And see, here is my reactor. Let me take a line bay. This is my reactor and transformer. Because I took P2 on the reactor side, because reactor is my protective equipment in that in case of the tie bay. So P1 here and P2 on the reactor side. And the core allocations, like this 2 core I took and connect with the line protection release, which is near to the P2. Okay, Vishal?
Yes, sir.
And this is my metering core. So the core 1, core 2, core 3 that I took and then connect with the line protections. So here energy metering, this is combined here, and both core which is coming on the P2 side, it is connected to the relay, and then it is here the 4th core, which is for the metering purpose of the tie bay, and 4th and 5th, in this case 4th is spare core, so just make a star point and ground, and 5th core is for the bus bar protections, LBB, local backup purpose. So I took P1 and LBB, and that I combined with the overall differential protections, which is the reactor I'm using here. So that is why I put the 87R, and then I connect with the. So LBB is coming here. 87R.
And if we
about the LBB, it is not correctly indicated, means that could be combined with the bus bar. It could be combined with the 87BB as well. I'll take any other example in that, I'll take what is the connection for that. 37 are okay because this is the overall differences. In the overall differences, we are covering that code. Means what I'm doing that here, yeah, that this SLD is correct. Means this tie way, this core I'm utilizing for the dual purpose. One, this CT core will feed to the local breaker backup protection for the tie way. Plus this CT will feed to the overall differential protection zone as well. Okay, Vishal. Anyway, when I will come on the SLD model, when I will discuss about the one-half scheme, I will take this point again. Okay, it could be not clear. Few engineers who do not know about the 1.5 acre scheme. So you note down and then we can discuss it in the 1.5 acre scheme when I will discuss.
And sir, in case the CT cores are placed on both sides of CB, in that case, how we can define P1, P2 in both sides?
Same as we discussed. Same as we discussed. I think you do one thing, you revise the class, then you come back. Same. This point already we have covered when we have done the core splitting. In the core splitting, I think when we discuss, we have decided now, what I can say. When I was discussing the core splitting, at that moment I have drawn
what is to be protected is the most important, and we are minimizing the blind point in that one. So we are using the core sensitivity. So
I will take, if I have any dual split core SLD, I'll show you that one as well. Okay, Visa.
Okay.
Hello, sir. Sir, can you go back to the combined CVT
It's not clear.
Sir, can you hear me, sir? Hello.
Yeah, Hari, your voice is not clear. So could you come again? Could you repeat?
Sir, I was asking about that combined CT and VT diagram, sir.
The SLD
combined CTPT. He is asking about the combined CTPT.
The SLD symbol?
Yes, sir. Yeah. That before, what is it, sir? Before the two arrows coming, I don't visualize that.
The arrow is indicating the cable there.
Okay, cable, right.
I'll tell you what happens. In this particular substations, before substations 200, I think it was 400 meter, 400 meter away to the substations, we are converting overhead line into the underground cable. Overhead line convert into underground cable. Hurry, okay?
Okay, sir.
At the conversion point, we have indicated the surge arrestor, okay?
Okay.
And then from that conversion point, this symbol we use to show the cable in the SLD. Okay, Hari? Dotted.
Okay, starting. Okay.
And then it is coming here. And then it is connecting here. So this symbol from here to here, it is cable.
Length of the cable.
Okay, then cable coming, and first of all, where it will connect at the side, cable ceiling in, right?
Okay.
Right now, Hari, isn't
Yes,
it?
yes, sir. Yeah, yes.
But
yes.
ceiling, so you can see this symbol is for the ceiling end. Okay.
Okay, sir.
Generally, ceiling end we do not indicate in the SLD, so that's why it is not indicated here. Ceiling end we indicate into the layout drawing. Okay.
Like termination, right, sir? Termination, right? Cable termination.
Is that termination gantry?
Yeah, termination. Yes.
Okay, sir.
And then after that, this at the ceiling end means what happens? We are in cable enter, and then we have the bushings, and then we can connect the overhead conductor or overhead T tubular bus bar we can connect here. Okay, so from that tubular bus bar, it will connect with the combined CTVT. Okay, Hari. And then this symbol is for the current transformer.
Okay, okay. Sir, one more doubt, sir. Do you have, sir, can you?
Yeah.
Sir, you told
Yeah.
me, you told
One
us.
second,
Yeah, sir,
One second. I think someone, Vishal, you sent the drawing right now.
Yes, sir. I am asking that in both CT cores, the P1, P2 is changed in both sides. So how can we decide the direction of P1, P2? And that I'm asking.
This is what we discuss. That's why I told you to please check here. The same thing we discuss, Vishal. What is the concept? What is the basic thumb rule? P2 where? P2 where?
P2 shall be at the bus.
P2
shall be at the lower.
P2 protection zone, right?
Protected part. Sure.
Correct,
Yes, sir.
Protection zone. This CT is for what? Line protection, correct?
Yes.
This we discussed now. This CT for what?
Okay.
Line protection main one.
Okay, understood.
Understood, right now. CT2, line protection main 2, CT3, line protection. This CT3 would not be line protection. This CT would be for metering purpose. Okay. Vishal? Okay.
Okay, sir. Okay. Understood.
This both CT core 1, core 2 for what? For what? Bus protection. What is your protection here? Bus bar? Isn't it?
Yes.
So P2 where? Bus bar? Right?
So why this intermediate CB is there? This is for the GIS?
Yeah. Yes, this is for the GIS. Yes.
Thank you, sir.
Yes. This is what we discussed. The core is splitting. Okay. Vishal, this is core splitting.
Yes, sir.
Okay, this core splitting in SLD and this topic already due to that reason my classes going so much 15 classes 14 classes I do not progress with my syllabus because I want to touch each and everything. This is the actual GIS CT here breaker here. Okay, fine.
Sir, I am Harshil here.
Okay. Yeah, tell me. One second, Harshil. Vishal, I hope your doubt is clear now.
Okay, sir.
Why I'm doing that? This is also clear, right? Why I'm doing that, or why I'm not doing is why this company is doing that. This is a concept over here. Okay. Yeah. Yeah.
Sir. Yes, sir. In the 220 kV system here, sir. Main bus 1 and main bus 2 will be in the model in the picture, sir. At the time of the bus coupler, sir, how to decide the city locations of the bus coupling, sir? Because of they have one breaker. So which side of the city will be connected at that time, sir? In the bus coupler time, sir?
Earlier we are placing CT on both side of the breaker, but nowadays we not placing CT on both side of the breaker. We are placing CT either one side of the breaker, and core we are allocating.
Oh, okay, sir. Okay, sir. Means any side, sir, is okay, na, sir?
Yes.
Okay, sir. And
I'll take anyway. This is all.
And another thing, sir.
This all I will take when I will come on the assembly preparations once again. You don't worry about that. Okay, you can see.
Okay, no issue, sir.
You can see here. I have the main bus 1, main bus 2. Okay.
Yes, sir. Yes, sir.
I have breaker. I have breaker here. I place the CT.
Yes, sir.
So
sir. Yes, sir.
CT after the breaker. This is the point. That place.
Okay, sir.
Here.
Okay, sir. And sir, another thing is that sir, tariff metering cubicle, sir.
Main bus 1 to main bus 2. This is how we are doing from main bus 1 to main bus 2 side.
Okay, sir. Sir, another thing I telling you, sir. Tariff metering cubicle, sir. Sir, PT and city location will be interchange. Any problem will be occur, sir?
First measure the voltage, then measure the
Okay,
current.
sir. Okay, no issue, sir. Okay, thank you, sir.
Okay.
So one thing in that one. So we are measuring the current first, in metering. So
Yeah, miss.
our current is
Yeah,
moving
in
per
case of,
pivot.
yes, in case of, yeah, correct. First measure the city, then
Here it is
Otherwise, we are losing the losses inside the PT in the
yeah, sir.
this line is for
I
exporting.
take back my sentence, sir. CT first, VT then. CT
Yeah, this
first.
is exporting line.
Yeah, because this is exporting line. Export.
One more thing to your added knowledge. One of the main client in Oman, now they are using class PX for the metering also.
Oh.
Okay, the oil and gas client video.
Yes.
Nowadays they are using PS class for the metering also.
Yes.
You have any idea why they are using?
PS
I'm
class.
also
PS class accuracy is 0.1%. PS class is
now they are using PS class for the.
Yes.
So there is no new designs. There is no metering classes. All protection, all classes are the protection classes for metering. Also for
they can use because in PS class now this in metering class the error is 0.2%, right?
Yes.
When it comes to PS class, this error in the PS class is error 0.1%.
Now it's for added advantage for the other participants.
Yes, correct.
And also this P1, P2.
But make sure this current, whatever the current you are taking, do not take very much margin in the current.
Yes. And also, I think this P1, P2, S1, S2 will be clear on the protection studies where to be placed, I think.
Yes.
While we are discussing that.
Yeah.
Sir, the accuracy is 0.1, it's okay. But what about the knee point voltage?
Sir, in metering, you don't require
metering, it will not affect.
As we discussed, in metering core, the knee point voltage is much less than protection core.
Yes. So
what we are using, the protection core, what we are using, the knee point voltage will be high. So it will not affect any problem. It will not go for the saturation also.
Yes.
So it's only
no sir, he is right only.
Designing for a
sorry to interrupt.
It should go to saturation, no? During fault condition,
No,
it should
sir.
go to saturation.
Is right, sir. If you are using a PX plus CT for the metering, if, for say we are using a low knee point voltage, during the fault condition, the CT will get saturated. At the time, metering CT will not read anything, right?
And that saturation is desirable.
Low knee point voltage for
metering.
Yes,
low saturation level they take.
Yeah, in that case, I think the meter will read the fault current also. The
then
fault
maximum demand will
also be
get changed.
No. My question is, meter will never read any current. Once the CT gets saturated using the PX plus CT, how can your metering CT will read the current?
Purpose is actually to saturate, right? Otherwise, meter will get damaged, right?
That metering core should get saturated.
That's why we are using that.
Metering core will saturate for fault current and protection core will not saturate for fault current. When we are using PX class, accuracy will be 0.1, but at the same time, since our knee point voltage is high, so PX class will not saturate for the fault current. That means our meter will read the fault current also.
That's my question.
Correct?
Yes, that's my question.
I think the client has no issue billing that fault current also.
And also, I think they're inside to the users resistors also across the meter.
But won't the meters, etc., will get damaged?
not register. They, as I raised this question in that city class, sometimes they provide a coil inductor across that metering core. So it will oppose the change in sudden change in current.
Correct. Yes.
Anyhow, I will next day I will try to share that SLD. Okay.
Yeah, please.
May I know which utility is
there is-
asking that PX plus CT?
Which
client is asking PX plus CT for metering?
Petroleum Development Oman.
Okay, Oman.
But there is one more point we can add, that might be they are using a low saturation, low knee point voltage CT for the metering purpose, because in the protection purpose, when we use the CT, in that time, at that moment we take higher knee point voltage for the CT, because we do not want CT saturate before relay operation. So there might be case that in that case CT they are designing having low saturation level. So might be they are using the protection PS class CT with ABT meters with low saturation level. There could be the case or possibility.
Yes, yes.
Okay, thanks Abu Hamid to share your Oman experience with us as well, so that when we saw that SLD, we will not feel surprised. Okay.
Thank
Okay,
you.
any other point regarding today class? Please share me your feedback, how it was for you. And
one question I can ask, Raghav?
If it is not important, let us discuss tomorrow, Hari.
Okay.
Yeah. Are you speak with one-to-one with me? Okay. Or we can discuss it tomorrow. Okay. So could we close today? No?
Sir, just for a couple of seconds. Dinesh here.
Yeah, Dinesh.
Hello. Just I was searching for this PS class knee point voltage. Even though there are multiple tapping, the tapping has multiple knee point voltages. So there are also the lower knee point voltage for the metering point also.
Yes.
Yes.
Yeah. So that might be reason the particular metering will have the lower knee point voltage, and rest of the things will
Yes.
as required for the protection purpose.
Yes.
So I was searching for this something. Compton instrument has given this some data on the PS class.
Okay, thanks.
I'll share it so you can discuss it.
Yeah, please.
I'm not sure, but it may be help us.
Yeah, you share in the group that we can. Okay, thank you, Dennis. Thank you.
Yeah, thank you, sir. Yeah, good night.
Thank you. Thanks for joining. Thank you, Sheikh Saab, for sharing your valuable knowledge with us. Okay. Your utility experience is very much important for us. Okay, thank you.
Thank you.